fifth lecture of making semiconductor. I will call you about etching and processes. So, we talk about what is etching. Etching is delete oxidation barrier, which is not laid photoresist. Important thing of etching is selectivity. The targets of etching are silicon dioxide, silicon nitride, and metal. Silicon is divided into isotropical and anisotropical. Isotropical refers to cutting in the same direction, and anisotropical refers to cutting in one direction. So, I can choose according to the design I want. There are also wet etch and dry etch method. Wet is cheap and easy to control, but usually ISO is used. Dry is used as an ISO and expensive, but you can control well. Here, it is important to know how fast etch, uniformity, method, and selectivity are possible with figure of merit. Wet etch is the basing route in which the dissolved solution moves to the surface, reacts, and the byproduct exits the surface. The etch rate here depends on the temperature and the chemical reagent. Dry etching is safe and desirable, but it can be used differently. It can be finely controlled, but there is drawback that it is easy to leave a residue. It can be divided into plasma and non-plasma, and when there is no plasma, it is used as a gas base, and there are many differences depending on the temperature. Basically, it is divided into ion buffering and milling. Argon atoms are used to ionize the plasma and apply a positive or negative voltage. This has the disadvantage that it is difficult to make it selectively and crystalline can be broken. Reactive ion etching is the case of adding gas, but it has the disadvantage of increasing the etching rate. But there is a disadvantage that it can go to ISO from an ISO. It can damage the surface, and the uniformity varies depending on the density. Deep reactive ion etching refers to the process of deep current etch in the state of SOC and current flow. In addition, the coil is wrapped on both sides to upgrade by inductance. When I call you the process point of view, there is a process to make the aniso process by adding Teflon on both sides to make the film less shaped and oxide it into an